Welcome guys, hope you're doing fine, and as you can see here we have a question from IOQM or PRMO of last year, and this is also another easy solving but hard looking question, so let's see what it is. So for a positive integer n, it can be called beautiful if n can be written in one and only one way, as n is equal to a1 plus a2 plus a3 plus so on up to ak, which is also equal to a1 into a2 into a3 into so on up to ak for some positive integers a1 comma a2 comma a3 comma so on up to ak, where k is greater than 1 and a1 is greater than or equal to a2 is greater than or equal to a3, so on up to ak. So there's an example here. 6 is beautiful because 6 can be written as 3 into 2 into 1, which can also be written as 3 plus 2 plus 1. And this is the only way you can do this. You can't figure out any other way to do this. But 8 is not beautiful since 8 is equal to 4 plus 2 plus 1 plus 1, which is also equal to 4 into 2 into 1 into 1. And there's another way to do this. 8 is equal to 2 plus 2 plus 2 plus 1 plus 1, which is equal to 2 into 2 into 2 into 1 into 1. So there are two ways to do this. So the uniqueness of doing this is lost. So what we want is the largest beautiful number less than 100. Okay, let's see how we can do this. So here's the solution. First we have to know what semi-primes are. So semi-prime is a natural number n which can be expressed as the product of two primes. They don't necessarily have to be distinct, as far as I know. So let's take a few cases. Let's take n having two positive divisors. Basically n is a prime. So we will have only one way of doing this. N into 1, which is equal to n plus 1. And this does not hold true, clearly, because n plus 1 is 1 more than n into 1. But this is the only possible way you can try to do this, at least. So for n being a prime, p let's say, n is not beautiful. Now let's take n as a semi-prime, that is 4 divisors. So we have n as a semi-prime such that n is equal to pq, where p, q are primes. And the other two divisors will be 1 and n, of course. So we will have two cases here. The first one, which will be looking like this one. pq into 1 is equal to pq plus 1, which does not hold true, as you can see. The other case is more interesting. You'll have p into q into 1 into 1 into 1, so on. And this is repeated pq minus p plus q times. And this is equal to p plus q plus 1 plus 1 plus 1, so on up to 1, of course. But this is repeated pq minus p plus q times. That's what matters. Now, this doesn't really affect the product, but if you substitute this here, you will figure out that it is holding true. So therefore, n as a semi-prime holds true, so n is beautiful for n being a semi-prime. Now let us try a different number of prime factors. If it has 3 prime factors or more than 3 prime factors, except 4, because 4 is what makes n a semi-prime, which is beautiful. So for n having greater than or equal to 3, excluding 4 prime factors, then you can make various combinations. If you remember the example given there, we had 8 and its factors are 1, 2, 4, and 8. But the prime factors are only 2 and that's it, just 2. And there are 3 2's. So you can make various combinations out of them, like 2 into 2 into 2 and 4 into 2, and that's it. You can figure this out on your own. For any semi-prime, this will hold true, but for any other number which is not a semi-prime, you will have either multiple ways of doing this or just no way of doing this. So therefore, we can arrive at the conclusion that only semi-primes are beautiful. So let's see what we can do now. We can derive that the largest beautiful number lesser than 100 is equal to the largest semi-prime lesser than 100, because all beautiful numbers are semi-primes. at least we know that. So to compute the largest semi-prime lesser than 100, we'll start from 99 and go down. So you have to factorize all these numbers into primes and write their powers up there. So add up the powers after you're done. If the number is 2, here, well and good. If it is not, then forget it. Because here the sum is 3, and you can write it as 3 into 33 or 9 into 11. Yeah, those are the two ways you can write it. Now for 98, you have 2 power 1 into 7 power 2. And if you add up the powers, you still get 3, so you don't get it. But what we want is a prime raised to the power 1 into a prime raised to the power 1. So basically the sum should be 2. And here we have 97 is equal to 97 power 1, so the sum is 1 here, which does not satisfy. Then we have 96 is 2 power 5 into 3 power 1. You can make many combinations for this one. And finally, the answer, 95, because we have power 1 here and power 1 here. We want our sum to be 2. And as you can see here, 95 is indeed the product of 2 primes. So therefore, 95 is a semi-prime, and that makes it beautiful also. So therefore, the largest beautiful number less than 100 is 95. So that'll be your answer for this question. Hope you enjoyed this video. Thanks for watching. Like and share this video if you really enjoyed it. And subscribe for more videos. You can also watch my previous videos. I made an entire playlist for J advanced questions. I hope they'll help you. Thank you. Goodbye.